All right, everybody, we're going to get started now. So thanks so much, everybody, for joining us. Welcome to the first of what we hope might be many more of these kinds of webinar events with our community, just to engage with our community some more. And the aim really of these sessions is to try and educate and inform everybody involved with the serverless framework and people interested in the serverless framework. And as we experiment with the different ways of doing this, the format of this might change. So for this time, we're using a Zoom account. We may try different alternatives to see what might work best for our community. And I have to say, at Serverless, we're kind of blown away at the response. I think we expected some interest, but I don't think we kind of expected as much interest as we got. So thanks so much, everybody, for attending tonight. The obligatory Who Am I page. My name is Gareth McCumsky, in case you didn't realize. I am a customer success engineer at Serverless, and that just means that I help our existing customers who are building applications, if they have any questions or issues around the serverless framework, as well as working with our community to try and help with initiatives to educate and broaden the reach of the serverless framework. Previously, I've been building websites since the early 2000s, and my first professional sort of engineering role was around 2008, and I've been building serverless applications for approximately 3 years now. So just to set the scene for what we're going to be doing tonight, so everybody knows what to expect, we're first going to go through a bit of an introduction on serverless itself as an architecture and what that really means, and what serverless architecture consists of. Following that, we're going to take a look at the serverless framework itself in a bit more detail and how that applies to serverless as an architecture as well. And then it's going to be demo time, where I'm going to be building live, as terrifying as that sounds, a CRUD API. And it's going to be a full CRUD application with publicly exposed endpoints, which means that anybody can access it. It's going to be scalable and production ready. And then we're going to be taking a look at the Serverless Framework Enterprise Dashboard, which is a product that we provide to serverless developers to help monitor and manage their serverless applications. After which, we're going to end off with a QA session for anybody here on the webinar to ask any questions they might have about the serverless framework. So to get us going, what exactly is serverless? What do we mean when we talk about serverless? And to set the context, we found that serverless architectures are normally built around microservices. So microservices are a really cool thing. You might have heard about it. The big boys like the Ubers and the Netflixes are talking about how they've restructured their systems to run with microservices, and it sounds like a really compelling pattern to follow. The one problem with it, if you dig around with it for even a couple of hours, is that you realize that running all that infrastructure can be a very time-consuming task. You'll spend all that time setting up all this infrastructure you need to manage and run and scale your microservices before you've even written a line of code. So serverless is a solution to that problem. And really, the idea is to abstract away all your infrastructure to make it simpler for you to configure all the infrastructure you need to run your microservices and your application. To put it another way, it's about using managed services in the cloud to fulfill the role of all those containers and EC2 instances you would have run in the past with all that software that you'd have to install and manage yourself. So to take a quick look at what I mean by that, I'm going to just go through a few of the core serverless services that you'll find on AWS. And that's the talk tonight is predominantly going to be involved with AWS, simply because that's one of the most mature serverless cloud providers out there. An API gateway is probably the linchpin of a lot of serverless applications, and we'll be using it tonight in the demo. So API gateway is essentially a way for you to replace all those endpoints that you want to expose to the world. You want a front end that talks to a REST API, and normally you'd spin up a Apache or Nginx VM or container that can receive HTTP requests. API gateway takes that away and makes it easier for you to do that. And that means that you've got no load to manage, so you don't have to worry about running a machine. And API Gateway has capacity for up to 10,000 requests per second by default, with an extra 5,000 for burst moments. It also has features like request body validation to help you manage incoming data, Swagger support, and API keys to help restrict access to your API, and authorizer integration so that you can build JWT authorizers and so on into your application if you need some kind of authentication system in your app. The cool thing about API Gateway, though, is that there's no minimum fee, there's no hourly fees, there's no per minute fees. You only pay for what you actually use. So out of that 10,000 that you get per second, you pay for nothing if you actually have no requests coming in. And along with that, you'll see that there is a very generous free tier with API Gateway. And there are companies who use API Gateway that never end up paying a cent for it because they never actually go beyond the free tier. And this here will be a very common theme, as you'll see. The next one we're going to take a look at is S3. And S3 is essentially just a file store that you can store any file you want or document or any object that you might think of. It's essentially infinite capacity to store items. And with S3, just like API Gateway, you only pay for what you use. So here you pay for the gigabytes of data you store and for whatever traffic you might generate, putting items into S3 or reading items out. It also has the unique capability of being able to host a static website, which is really useful if you have a front end that consists of HTML, JavaScript, and CSS that talks to a serverless backend, otherwise known as the Jamstack. And also has the ability for you to control access to whatever buckets you have data sitting in with very fine-grained controls, or you could make it public, as in the case for a static website. It also has various levels of storage. So if you happen to store items that you very rarely access, you can change your storage options and save money. And again, this also has a generous free tier. So getting started with this can cost you nothing. DynamoDB is a tool that we'll also be using today. And really, it's meant to be a replacement for your relational database in a serverless world. It does take a bit of knowledge to get to know how to use quite well. It's a NoSQL solution, so your relational database knowledge might not transfer quite so easily. But it's a very, very nice solution for building serverless apps because of its infinite scaling ability. There's also no minimum fee, just like all the other items. You don't pay hourly or by the minute. You only pay for the data you actually store and for how much you read and write your data. And speaking about reads and writes, the upper capacity right now for a DynamoDB table is 40,000 what they call RCUs and 40,000 WCUs, write units and read units, basically. There's a bit of a calculation involved in that, but essentially it's a lot of data. You're talking about a few kilobytes of data per second times by 40,000. That's a lot of capacity that happens. And at that, if you start reaching that, Amazon themselves will probably contact you to find out how they can help you accommodate more capacity. So it's a lot of capacity that you can immediately bump up to and probably hardly ever reach unless you build really big apps. They also feature unlimited table size in the number of items and then just the volume of data that you might put in a table. And again, just like all the others, DynamoDB has a very generous free tier for you to try out. So you don't have to pay money just to try out DynamoDB. So Lambda is obviously something that we'll be using today. And Lambda is unique in that all the previous services that we've talked about have pretty much been around for most of AWS's life. API Gateway might be the newest of the lot we've looked at so far. But Lambda is a feature that came along because there was actually a missing gap in the sort of serverless space. All those other services are great to use, and if you wanted to use them, you'd have to incorporate them into your app that you'd then run on containers or EC2 instances. But in 2005, when Lambda was released, it essentially became the missing piece in serverless and provided compute as a service that allows us to glue all these other services together. And just taking a look at some of the details of Lambda, by default, Lambda allows you to run 1,000 functions in parallel at the same time. This can be increased depending on the region that you're in, but that's it can go up to 10,000 concurrent lambdas. So quite a lot of capacity you can handle there. It can be increased. Lambda is also nice in that you can only pay per 100 milliseconds of execution time. So you're not paying for an hourly rate for a VM or a container that you have to keep warm, waiting around for traffic. When you're not actually executing any code, you're not paying for any of that. And there's various performance levels, so you can tune your function to perform at specific levels and affect the 100 millisecond price range. And again, just like all the others, there's a very generous free tier with Lambda for you to try out that doesn't cost you anything if you don't go over it. And none of these free tiers that I've been talking about have that 12-month restriction. Those are permanent free tiers that exist for the life of your account. So why is all of this serverless stuff such a good thing? Well, it might be obvious, but I'm just going to say it. With serverless, there are no actual servers to worry about, and that's really where serverless gets the name from. So using serverless services like this, you don't have to worry about CPU, memory, disk, OS updates, application updates, network configurations, container configurations, Kubernetes configurations, Helm configurations, all of these things that you'd need a team of DevOps professionals to help you manage if you want to run a microservices-based application. Load is automatically accommodated for you by the limits that I've been mentioning with these services. So you know how far you can push these things before you need to speak to AWS to get an increase in your capacity. You have that number to play with. It's a guaranteed SLA. And scaling down is an interesting thing with serverless in that it's very difficult to talk about a concept of scale down for serverless because everything is event driven. When you use a service, you get billed for it. When you're not using it, it's just not in use. So what that means is that you can scale to zero, essentially. If something's not in use, you're paying absolutely nothing. So you pay for what you use, and that often becomes nothing, and often because of the free tier. The downside of all these nice services that you might find on a provider like Amazon is that manually configuring all of these pieces to work together can be time-consuming and error-prone, whether you do that through the SDK or the CLI or even CloudFormation itself. It can become a bit difficult to manage these things without having problems. So where does the serverless framework come into this? So first of all, the serverless framework is an open source project. It was started in 2015 by our founder, Austin Collins. And it's a fully open source project with an MIT license, so there's no restriction as to how you can use it in your application. And it's hosted on GitHub with over 30,000 stars already, so it's a relatively popular framework to use. And while we have a core team of developers that work on the framework and release regularly, we do have a very wide range of contributors that help us push out extra features, bug fixes, and so on. There's also, because of our extensibility with plugins, there's a very large community of developers who create plugins that extend the functionality of the framework for nice specific use cases. And you can just pop over to github.com/serverless to go take a look at the project itself. So the serverless framework helps in that it tries to define all the infrastructure you need for your service as code or as configuration. So all those managed services we were looking at before are defined as configuration as YAML or in code itself. We also have a CLI tool as part of the framework that helps you execute commands using that configuration, such as bootstrapping a new service or deploying a service into the cloud itself. And it makes deploying our infrastructure very portable. So if I'm a developer and I build a service with serverless and I commit it to my Git repo, another developer can clone that out and deploy the exact same configuration to their AWS account, and they'll be the exact same service because it's a mirror image essentially across different cloud accounts. And it also means that it makes it possible to configure cross-vendor applications with multiple configuration files. So you could have a configuration file for how to set things up for AWS, and a second one to set it up for Azure, for example. And that's just an example of what some of the CLI commands look like, and we'll be taking a look at some of these during the demo. And this is just an example of sort of the basic YAML configuration you might see in serverless. So I guess that's enough talking about serverless, and let's take a look at actually building a serverless CRUD application. So I'm going to start off here by just making a directory for our application we're going to be building. I'm going to call this the kittens CRUD. All right. So I'm going to be using the serverless framework to help bootstrap a new template for me, a new project for me. But I just wanted to show you how we have multiple templates as part of the serverless framework. I'm going to be using the AWS Node.js template, which means it'll be deploying to Node and to AWS and using Node as my language, as the runtime. But we support a large variety of different runtimes and providers. And you can start that off by just picking the one you want. So in my case, Node.js. And there we go. I've got a bootstrapped project to work with. So I'm going to go open up in my editor. And here you can see I've got three basic files, just a git ignore, a handler, and a serverless YAML. So we're going to start by looking at the serverless YAML file. And this is the central configuration for the entire serverless project that you'll be building. First of all, I'm going to go and edit my service name just to make it unique. And further along, you can see my provider is AWS, and the runtime that it's going to be using when it deploys is Node.js 10. We do support Node 8.10 as well, and we still support Node 6 until AWS decides to remove that. So I'm not going to go through all the detail of all this configuration. I'll be going through the items as I'm going to be using them this evening. So what we want to get down to is looking at our functions. And like I said, we're going to be building a CRUD application to create, retrieve, update, and delete kittens. That's going to be the entity we're going to be looking at. So to get started, I'm going to define what functions we're going to have. So I'm going to name the first function I'm going to create is going to be called create, because this is going to be to create kittens. And in the handler portion, the handler here is a file name, which will be this handler.js, and hello here would be the function name. But I'm going to make this create. Now I need 4 more because I need to have one to list, retrieve a kitten, update a kitten, and delete a kitten. So list a kitten, get, update, and delete. All right, great. So I've got my functions listed here, but at this point, they're not really doing anything. All I'm telling the serverless framework is that this file contains my Lambda functions. What I do need to do is add events to my Lambda function so that they will actually get triggered. And in our case, this needs to be API endpoints. So we need to add an event called an HTTP event. And I just need to set up some configuration for this. So I'm going to set up a path with the versioning. This is going to be for kitten. And I am going to make the method post for a create. General REST stuff. I need HTTP for the list. And I'm just going to copy this event now to the other ones. Alrighty, and this one is going to be also a get. Now for this one, I'm going to want to pass a parameter to retrieve a specific kitten. So I'm going to pass the kitten's name, which will be sort of my unique ID. For an update, this will have to be a put request, but I also need to pass a unique ID so I know which kitten to update. And for my delete, I also need to pass a unique ID, and this needs to be a delete method. All right, great. So now I've defined what my functions are going to be and what's going to trigger them. It's going to be HTTP events. So now let's go and actually create our functions. So this is the default function, and I'm going to tweak this a bunch. And what I'm going to do here is I'm going to be adding all my functions into a single file. And there's various ways that you can do this. Some people prefer to add one function per file. Some prefer to put multiple functions in a single file. The serverless framework itself isn't opinionated about how you build these things. As you can see, we only provide you the 3 basic files to get started and the framework in the back end for managing your deployments and so on when you're ready. The point is that you can build your application the way you and your team decide you prefer to build it, lay things out, structure your folders, and whatever else you decide you want to do in your team for your application. For us, I'm going to create a basic collection of functions here. And I'm just going to copy these over for the others. And this one is going to be the list, the get, the update, and the delete. I just want to confirm. Yeah, I've gotten that right. Yep, there we go. All right. So to get started, the create event is going to have a post body, and this event object ends up being populated by the event that triggers the function. In my case, it's API gateway. But for any other events that exist, that can be pushed to a Lambda function, such as an SNS event or SQS or S3 even, all these events can trigger from the AWS cloud into a Lambda function. In this case, like I said, it's going to be API gateway. So the event object will have a body property. So I need to check that I have a valid JSON object passed. All right, so I'm catching my JSON error here. And I'm going to, at this point, I'm going to console log there. And because this is an error now with the data that's submitted, I cannot process any further. So I'm going to return to the caller a status code of 400 because the client that sent the message didn't send the right message. So you might be seeing this console log and wondering that looks really strange. If you did that in a normal application, you'd end up printing something to the web browser log or somewhere else that you might not want it to be seen. With a Lambda function, this console log actually gets printed into your CloudWatch logs, which only you can see or have access to. So console log and any other derivative that makes use of console log is really useful for this purpose. You can push logging messages that you might want to have access to later if errors seem to happen. So now that I've checked for my JSON body, I'd want to check to make sure that I have the actual items that I need. I need a name of a kitten. And I'm also going to check to make sure that, I don't know, what should we have? Age? Let's check for age of a kitten. Great, and if I don't have either of those, again, I've got a problem. So I'm going to console log missing parameters. And then I'm going to return the exact same error message to the end user. At this point, I need to now make use of the AWS SDK to actually push this data into DynamoDB. So I'm going to use NPM, and at this point, I'm going to also init NPM just so I can use some NPM modules. I'm not interested in the bootstrap information. So I'm going to install, the AWS SDK. And while I wait for that to install, I'm going to define it here so long. Great. So now the AWS SDK is available to me to use. I can close that. And I'm going to now define some put params for DynamoDB because I want to put a new object into DynamoDB. At this point, I need to use some syntax for the SDK for DynamoDB. This is all documented in AWS's documentation, but it's relatively simple. At this point, I need a table name to put stuff into. So I don't know what that's going to be, but I'm probably going to have an environment variable that I want to use, and I'm going to call this the kitten table. And let me go set this environment variable up. So in our serverless YAML file, I'm going back to here. I can set environment variables that will be available to my Lambda functions while they're executing. So I can define them here, and serverless framework will make sure that these environment variables are available to every Lambda function when they execute. So I've called it that one. I'm going to call this the kitten table, and we're going to edit this in a minute. I'm just giving it any name right now. And now that I've got that, I need to put an item in. So I'm going to put an item with the name, and it's going to be body object name and age. And I'm just going to put the code out to define this. Put the result. I need to instantiate DynamoDB. So now I have access to DynamoDB, and I'm going to be putting the put params and make that a promise so that my await in node works. And now I need to catch any errors from my try block. DynamoDB has never gone down since I've used it, but you never know. Things can happen, so we need to make sure we catch any errors there. There's a problem putting the kitten. And we need to return, maybe actually I will log something extra. I will log my parameters here. Useful for debugging purposes. And at this point, I'm going to return an error to my user because I was not able to actually put it in the table. And this would be a 500 error because there's a problem. There's a sort of server error here that the user can't resolve by changing anything on their side. Great, so I'm catching all of that. Now, lastly, I need to make sure that the put result would have succeeded at this point. So now that I've finished that, I can actually go and return success to my user. Return. Great. So now I've got the create portion done. Let's do the list section, and we're going to use a method of the SDK for DynamoDB that you probably won't use a lot in production, but because we're being very light here, it's not a problem necessarily. We're going to this is a very short-lived API for us. So I'm going to define the scan params. Again, we're going to be using this table name. I'm just going to copy that from up here. And that's all we need to scan the table. And now I need to scan result. So we want to pull a list of all the kittens with this. And normally you would have some kind of query here that you could filter by. You're not necessarily going to scan the entire table. Let's copy and paste that. And scan result. And we're going to promise that as well. Great. So again, I need to just catch this. Catch, not try. And I'm going to pretty much catch with the same information here. There was a problem scanning the kittens. And, oh, yeah, that's why. Scan error. Great, now I need to check that my data actually returns something. So if I just make sure that the items returned in scan result dot items is if it's equal to null, or if it's not an array, or scan result items dot length is equal to 0, then I need to return, because the item there's no items in the table. Great, so now I'm managing those items, and now I need to return the items that I did find. Need to take a sip of water. So we return status code 200 with a body. So we can return a body here, make sure it's a JSON string, and we make this the scan result.items.map a kitten. And this is going to be return a kitten by name. And we want the age. Great, now we're returning the list. So now if we want to get a kitten, what we've got, because of the serverless YAML, we have our get here has a name. We can now use that when we do the get request. So I'm going to set up the get params. And this goes through a similar process where now I can actually specify a filter of the unique ID for that kitten. And that's going to be key, where name is equal to the event object here, which contains a property called path parameters and .name, because that's what I called it in my serverless YAML file here. And now I can do get result. We can do a try block again. And then the get result is going to be equal to dynamodb.get great. Now I need to catch again the get error, and I can grab my log here. You can already see there's places that you can make it more efficient by abstracting out these sections that are repeated. I'm just keeping it simple for now while we do this demo. Now, if the item doesn't exist, we would have the item that's returned would end up being null. So I just need to check to see that the item does actually exist. So if I look at my get result object that was returned, item, if it's equal to null, that means that I return a status code, once again, of 404. Otherwise, I can return the name of my, status code again of 200. The body is going to be a JSON string with a name parameter being the get result .item.name, and the age being get result .item.age. Great, so now I can take this get, kind of like that. We can drop it into update here. And the only real thing I need to worry about with update is the data that's passed for me to update. So that I'm going to quickly grab from up the top here in our create, where we test our body. Bring that down to my update. And I'm just going to make sure here that I remove the check for name. Name is going to be used to find the object we want to update. We're not going to change name as part of the update, only age. Otherwise, missing parameters. Then we build the update params. So I'm just going to update that quickly. The additional item we need to add here is an update expression. So that just tells DynamoDB what the item is that we're actually updating. So I need to set age equal to age. And now I need to define what those expressions are. So expression attribute name, set the age equal to age. That's what our column name is going to be. And then we need the value for age and expression attribute values. And that's going to be age. And that's going to be equal to what was passed in our body object. Great. So now this is these are proper update parameters. The get result, I just need to rename that to update result. the get error, I'm going to update to update error. This is going to be an update request with the update params. And at this point, I don't need to check that the item exists because we've already done that with the update. And I'm not going to return the body because the person has submitted what they wanted to update. So I'm going to just return a 200. And that means we don't need the update result, and we can actually remove that here as well. Cool. Last one we need to do is the delete. And again, I'm just going to copy my get here because this basically provides all we need for the delete. We'll be removing just a couple of things. So first of all, let me change get params here to be delete params. I need the table name, I need the key to know what to delete. I need the get result to change into a delete result. And this needs to change into a delete call. There was a problem deleting the kittens. This is going to be a delete error. And we don't need that because it's obviously going to be gone if we're deleting it. And we can't return a body because we've deleted it. So I'm going to remove that as well. There we go. We've now defined our function and what it's all going to do, what the CRUD is going to actually process. So right now we have a serverless YAML file defining our functions, what's going to trigger them, and we have a handler file containing our functions and what they're going to do. And so at this point, then I'm going to use the serverless framework to actually deploy into AWS for me. And there's numerous ways that I can decide how to pass my AWS credentials. You can use environment variables. There's detailed information about this on the serverless.com website and AWS itself. I tend to like to use a credentials file in my .aws folder because I have access to multiple AWS accounts, and it's easier just to keep track of things that way. So what I'm going to do is use the serverless command to deploy. I want to use my AWS profile called serverless. And I'm going to give this a stage called dev. And stages are just a way for you to separate out what environment this specific app is running in. So stage dev, you'd have this as a dev environment. And you could have a different AWS account for dev and a different AWS account for prod. And that should do it unless my YAML file is broken. So while this is deploying, I'm letting this create the stack now while we do some other things so that the stack is created by the time we're ready to start experimenting with this. What we do need to do, though, is define our DynamoDB table, which we haven't done yet. So if we go to our serverless YAML file, I want to go to a section here called resources. And this is where I can define any additional resources I need outside of what the serverless framework does for me automatically. And Serverless Framework doesn't automatically create DynamoDB tables for me in the sort of nice, pretty YAML that we've been looking at. I can use CloudFormation syntax here to define my DynamoDB table. And this is really useful because it's not just limited to DynamoDB. I can define anything I want here. But we're going to keep it simple, and I'm going to create the kittens table. That's the name of this resource. I need to define the type, which is going to be AWS DynamoDB table. And the properties of this table are that it has a table name. And the serverless YAML file has the ability for you to use variables. So for example, I like to name my resources here by starting it with the service name so that it sort of separates it out from any other services, any other tables or anything else I might create with a similar name like kittens. And then I like to add the stage on as well that I'm in so that I can add dev, prod, what have you to the name as well. So that I make sure I don't overwrite things if I'm deploying to the same AWS account. So this table name will always be unique. Now, this table name is what I need in my environment variable. So I'm just quickly going to edit that. So make sure we have the correct table name in our Lambda functions when we deploy. And now I need to define my basic keys. So with DynamoDB, you don't define the entire schema. You just need to define your keys that you're going to query on. So attribute definitions we start with. My unique key is name, my kitten names. And I'm going to attribute type. So it's going to be a string. And now that I've got that, that's the only field that I actually care about at this point. I just need to get this in. There we go. I need to create the actual key. So the column I'm interested in for my key is name, and the key type this is going to be is hash. And I'm not going into the detail of all of these options right now. There is documentation for this. And if anybody has questions afterwards, we do have a QA session. We do have our forums and so on. And I'm going to set a billing mode of pay per request. Okay. So right now I'm looking at a DynamoDB table, and this is all I really need to get a basic table up to persist data. And let's take a look. We have our stack has deployed in the meantime. So we have a new API, API gateway stack here. For some reason, I need to just confirm my YAML settings here. I'm going to deploy again. And this will create our DynamoDB table. Let's see what option. Oh, yes, I need to. That's a typo on my part. This needs to be stage. And obviously another typo somewhere, another opdev. Oh, yes, that was on a copied environment variable. Someone's watching. I can't type. All right, it's deploying now. So now what the serverless framework is doing when it's deploying here is it's essentially taking my configuration in the serverless YAML and producing the CloudFormation I need in order to deploy all these items into AWS for me, including an API gateway endpoints that I need for my functions here, and the DynamoDB table that I defined down the bottom here. And like I said, you have different events for your functions. You could have events triggered by the SMS service from AWS, the SQS service from S3, for example. If somebody puts an item into an S3 bucket, you might want a Lambda function to be triggered off of that. There's very many reasons why you might want a Lambda function to be triggered by many different AWS services. And by using the events property here, serverless framework is automatically building all that CloudFormation that would otherwise be incredibly complex to try and build on your own. Just waiting for the deploy to finish. And let's hope my debugging when I run these API endpoints isn't going to be too monstrous. Almost finished, almost finished, almost finished. Just takes a minute. There we go. The stack update is finished, and we should see here are our endpoints. So I'm going to copy these out right now, and I'm just going to create a quick little test file for us. So new file. And this is a post endpoint. This is obviously a get endpoint. This is another get endpoint. This is a put endpoint. And this is our delete endpoint. So what we should be seeing is if I come along here and add a body, I want to add a new kitten called Fluffykins. And Fluffykins is 4 years old. That should be enough. Let me see if my request will fire properly. It won't. And the reason why is because I haven't specified my permissions for the serverless framework. So that's one of the features of serverless, when you build a serverless application, is that your access to anything is nothing. You have zero access to anything unless you explicitly specify it. So what I mean by that is these functions need access to DynamoDB, and they don't have it until I configure that explicitly. So this is good for security and means that you can maintain complete control over what your functions have access to. So here, I need to add some permissions. I'm just going to allow access the action, and I'm going to speed things up slightly. I'm going to cheat a little bit and copy something over. Ta-da! Now, what I've done is I've given my my functions access to put items, to scan items, to get items, to update items, delete items, and I've specified the exact item that I need. I'm using another feature of the serverless framework, one of the plugins called the pseudo parameters plugin. And plugins are easy enough to use. I can actually just install one using npm. And really, this is a simple plugin, but what it does is it allows me to use much nicer to read syntax to access CloudFormation variables that are sometimes a bit tricky to get out. You don't need to know the specifics of this, but what this does is it adds extra functionality into serverless framework that didn't exist before. And now I can use syntax like this to pull my current region from where I'm from the account to the account I'm deploying to, and the account ID for the account I'm deploying to. And all I need to do is now activate it by providing the name of the function here. Great. Now I should be able to deploy again. And once the deployment finishes, it will have given all my functions permission to access DynamoDB, but only on that one specific table. And I want to make sure that I've gotten the name right. Yeah, I have. And only these specific permissions. So yeah, I cannot create additional tables. I cannot delete tables. I cannot do anything that I'm not allowed to, only specifically to items. Yeah. So if somehow my service got compromised, if there was some injection attack or something funny like that found its way in, my restricted access here means that my items are safer than they would be if I just allowed all access to everything. So once we completed the deployment, we should then be able to do our post request. We just need to wait for the deployment to complete quickly. Won't take long. And there we go. It's updated already. Great. So let me run my post request. You see, there we go. Yay, it's been created. So let's get all of our items. Yay, Fluffykins is 4 years old. And if I replace my little parameter box here with Fluffykins itself, my get request should return just the one object, not an array. Oh, I've got an error. So the interesting thing is with errors, I can also with serverless get access to my error logs without having to go into AWS at the moment. So I need to go to serverless logs. The function itself is called get, and the stage was dev, and that should pull my logs. So I can see exactly the error that happened. And my AWS profile, maybe. Yeah, there we go. And cannot read property name of undefined on 1110. So we could take a quick look at our handler on line 110. And let's go create Fluffykins. Let's get. Oh, that's a put. We're going to do get. Oh, Fluffykins, why do you have to be so difficult? Right, I'm actually going to move on. We are running short on a bit of time. But yeah, you can see we can add age and make Fluffykins 5 years old instead. And Fluffykins is now 5. So if I do the scan, we can see Fluffykins is 5. And if I do a delete to Fluffykins, and Fluffykins should be deleted. And there we go. So that is the basics of building a CRUD application that you can send endpoints to. And at this point, I'm also going to pull that down. So when I've finished building a serverless service like this, I can actually just remove it. Oops, typo. And now this is going to remove my stack that I've created because I no longer need it. It's removing all the items it created, including the API gateway endpoints, the DynamoDB table. There are ways to keep that if you need. You can set configuration for DynamoDB so you don't accidentally lose all your data. I didn't in this case, and I'm not really bothered. But it's a nice way for you to quickly deploy something, quickly try it out, and then just remove it immediately and not have to worry about it. So there we go. So that would be the demo of the CRUD application. So to move on, I'm going to talk quickly about the Serverless Framework Enterprise Dashboard. And I know time is running a bit late for us, but I'm going to be as quick as I can. So just to talk about it quickly before I do a quick demo of that, the Serverless Dashboard is essentially a way to help you manage and monitor your applications. First of all, it allows you to control access to AWS accounts by developers in your team so that you don't necessarily have to give access to AWS accounts for developers to deploy to staging or production environments. It also lets you set up deployment policies through what we call safeguards, which helps you control the configuration of YAML files that might get deployed into AWS. It also lets you manage your secrets per stage, so you could have different secrets for dev versus production stages. And lets you keep an eye on the invocation activity so you can see how busy your functions are, what errors might be happening as well, and the running time of your Lambda functions as well, as we'll see. And we also have on the Serverless Dashboard a free tier available for anybody to use. So you can go ahead and try it out. The limit on the free tier is 1,000 invocations per month. But that limit doesn't affect anything but our ability to log. So after 1,000 invocations, we stop logging after 1,000 invocations. Your function still executes, safeguard still works, and everything else still lets you deploy and keep running your application. Great way to test out the Serverless Dashboard to see if it fits your needs. And yeah, there's a picture of the dashboard that we're going to take a look at right now. So here is the Serverless Enterprise Dashboard. It's this is the page where I'm viewing my applications. As you can see, I've already got one set up here. And an application, when you start, you'll end up creating your initial application. And you'll want to set up what stages you're deploying to your application. So in this example, I have a dev stage that I'm going to be deploying to. And I have a profile set up here for this dev stage. So to take a look at the profiles, and profiles are really where a lot of the sort of strengths is of the Serverless Enterprise Dashboard. Because here I can set up access to AWS accounts for a specific stage. So if I'm accessing the dev stage here, I can now give access to Serverless Enterprise, from Serverless Enterprise to my account, my specific account for my dev deployments. And the instructions here are available here that you can follow to set up the ARN needed for a role that allows the Serverless Enterprise Dashboard to access your AWS account and give you the roles to deploy to that AWS account when you deploy. And I'll be showing that in a second. Secondly, you have the safeguard policies, and you can see how I've got a couple set, but these are a great way to help control how developers build your serverless services that get deployed into your AWS account. If I look at adding a new one, you can see the list of options available here there's quite a few of them. Allowed runtimes, for example, lets you restrict what runtimes you allow people to deploy with. One of my favorites, though, is the JavaScript one, which allows you to essentially write your own safeguard that you want to interrogate the serverless YAML file that a developer might want to deploy and make sure that there aren't any settings that you don't like. Another one that I think is a really strong one is no wild IAM role statements. So where I was setting up my DynamoDB permissions before, you probably saw me put in the specific resource that I wanted to access. What you'll find is in development, as a developer, you might just put a star, which means any resource, which is a great way to quickly test things out. But in production, you probably don't want that. So this is a role that can help you catch if somebody accidentally leaves a wild IAM role statement. So just to look at what I've set up here, I've got a runtime limitation here to node 8. And I've got a stage to dev because this is my dev profile. So I want to limit the use of this to a dev stage. And there's also the option to set secrets, as I mentioned before. And I haven't got any set up here, but this, for example, for a dev environment is where you'd put the access to a sandbox account for your payment gateway, for example. And you might have a production profile as well, where you have your production credentials. And the nice thing about this profile section as well is that you can add team members, and additional team members can be collaborators or admins. And collaborators do not have access to profiles, whereas admins can set up new profiles and so on. So collaborators can have access to the application section. And we're going to take a look at this the service that I've already got deployed here and look at a bit more detail in the graph. So one of the things we have for this demo application is a little form that can help us simulate activity for the graph. So I'm going to let this generate some fake API requests just so we can see some activity. And I'm going to click a few times and create some errors so that it can get logged. And what you should see in a few seconds, you should see the bar populate here with these invocations as they're happening and the errors that I generated by clicking the button. You can see here's one that I prepared earlier. What you'll notice here is these dotted lines, for example, are where deployments have happened. You can already see here's errors coming through and some invocations as you watch. And if you're interested in see what these errors are, the dashboard lets you scroll on through to go take a look. And I want to see what my errors are there. There were 5 of them on this specific function. If I open this up, I can see the error type, and this is just a regular old node error. But expanding that further lets me see the exact stack trace. So this is the line that actually threw that error that I see in the graph previously. I can also see some of the dependencies which may have been causing that error, as well as the raw CloudWatch logs here if I need to see in more detail to try and debug the situation. Once again, helping any developers on the team immediately go and see what errors might be happening, look at the log files, find where the errors are being thrown, and go and fix them without having to go looking through CloudWatch logs, trying to desperately find where this error might be or any additional information. You'll see there's activity insights on the side here as well. This is informing me about escalation. So for example, I suddenly created 50 API requests, so that's an escalation of invocations. It's just warning me that suddenly I've got lots of activity. It's also showing me previously failed deployments. And the graph I've got at the bottom here shows me my durations for my Lambda functions. Again, a very useful feature when you can see when you've deployed and can then compare the duration of a function here versus one over here. Maybe you've made things less performant. And to get my service to deploy through the dashboard, through Serverless Enterprise, and to start monitoring is actually a very simple thing to do. So I'm going to take a look at the demo that I was talking about before here. And I'm just going to open it up to take a look and show you in the serverless YAML file. All I've done is add an app and tenant, so that this is the tenant name for what we were just looking at, and this is the application name that I created. And when I'm ready to deploy this through the dashboard, I will use SLS login. This feature is built into Serverless Framework by default. SLS is just a shortening for serverless. And when I do SLS login, it's going to open up my browser and allow me to log into the dashboard. And then that login will be registered on my local machine, so that if I deploy from that point on, and I don't give it any other way to look at AWS credentials, it'll deploy through the dashboard. So I'm just going to deploy this application. Oh, I just want to check something here. And what this is doing now is it's using my credentials to connect to the dashboard to then get a role returned that it can use to deploy to AWS using that role information that was set up before. But it's also pulling safeguards information from my account, from my profile. And if you remember, I had a restriction that said only 8.10 could be used, and here I've set it at 10.x. So my safeguard prevented me from deploying this. Like I said, that's just a demonstration of what it can do to help prevent things, that you don't want to go live. So that is the basics of the Serverless Enterprise dashboard. And like I said, feel free to try it out yourselves. We do have a free tier that you can use. It's at dashboard.serverless.com. And at this point, I think it's time for us to open up for any questions. So I'm going to open up the QA session, and I think I can do it through there. All right, so feel free to ask your questions. I'm busy looking at the questions asked already. And I do have, I think, a couple by email that I'm also going to get to in a minute. So from Michael Over, I have the question, can the functions in the handler share code? Yes, they can. Being Node, so I'm going to talk in the context of Node, you can use NPM modules and import those NPM modules as much as you like. You can create your own classes that you can also import into your functions, anything like that. When you deploy, all the code is bundled together and deployed into AWS for each Lambda function. And there are ways, if you don't like the idea of bundling all that code together, we do have plugins that let you separate that out and bundle things individually to make sure that you only bundle for each function what each function is potentially using. But by default, we include all code just to be safe, to make sure we have all the required elements you need. All right, another question we have. The question is, I see templates from Go language. So if I get it correct, I can deploy code in Golang instead of JS. And that is true. Yes, there is support for Golang. I'm not a Go user, so I can't really say more than that. But if you prefer Go to Node, if you prefer Python, Python's also a very popular language. That's also very much available. So the next question, there's a couple of questions here from Justin Spradlin. And he asks, first of all, is it possible to develop locally offline? So yes and no. Ideally, what you want to do when you're developing a serverless application is at some point, you will need to deploy into a cloud account, because you are going to be integrating into online services like DynamoDB, API Gateway, as you know the demo showed. And you do want to actually eventually test on those systems to make sure that your integration works. But developing locally, there are various means to do it. We actually have a blog post. I think it's the most recent blog post at serverless.com/blog that I happen to be the author of. And that is one way of developing locally using unit testing and mocking of the AWS SDK. But there are other means. There are ways to, for example, run a local version of DynamoDB. So you can execute on a local version of DynamoDB. And many of the AWS services, there are ways to simulate running them on your local machine if you prefer to develop and test that way. So there's definitely ways to test locally. There's also the Serverless Offline plugin, which helps you test API Gateway requests. So it essentially creates an HTTP server that you can send requests to test your API Gateway endpoints sort of locally. Automated testing, that kind of is the next question, and you can do automated testing with serverless. Again, if you look at the blog post I was mentioning, it goes into detail about using Mocha for automated testing locally. Integration testing is another great option with tools like Cypress, where you can create a staging environment on an AWS account and set up something like a Cypress or a Puppeteer to go and click on a simulated web page if that's the way you want to test that as well. So environment variables, the next question is, how are sensitive environment variables, for example, passwords, stored such that they don't appear in clear text in the serverless YAML file? All right, so you saw me use environment variables for a DynamoDB table. But generally what you want to use is a service from AWS called SSM. And what this does is allow you to store variables in AWS itself, and then it gets encrypted. But what you can do is we have the feature built in where you can use a variable, and I don't know if I can, it says I can type the answer, but I think I only send that to you. But essentially, where you saw me use something like the $ curly bracket self colon service, you could do something like $ curly bracket SSM colon, and then the variable name that you stored in SSM. So it allows you to access that information. However, what you saw as well with the dashboard is that you can store your secrets there as well. And we do have a similar kind of shortcut in your serverless YAML to access those secrets. So when I do an SLS deploy, that pulls my safeguards to make sure my serverless YAML is okay. It then goes and extracts my secrets and will, during deploy time, substitute my variables with my secrets I've stored in the dashboard. And on our side, those secrets are also stored in SSM. So we use the same feature on our side. We just include in the dashboard to help make it easier for you to maintain that without having to constantly go into the AWS console to try and manage those things yourself. And the final question from Justin Spradlin is, how is serverless similar or different than a tool like Terraform? So Terraform is a tool designed purely for helping you do cross-cloud deployments of infrastructure. It's a very different target market. Our target is looking at app developers, and we're helping people build applications using serverless technology. So that's really where the biggest difference is between serverless and other tools like Terraform. Terraform is if you want to spin up EC2 instances and RDS databases, and you might want some containers and maybe an S3 bucket or two and a DynamoDB table. Whereas serverless is focused around building functions where your compute model is on Lambda, and you use other serverless services to help you accomplish your app goals, essentially. Another question here from Tom Gerton is, for creating an API, when should you use Express or not? That's entirely up to you. There are two different camps on this. I tend to fall under the camp that Express isn't actually required at all. Express can add a routing mechanism on for you, but as you've seen during the demo, I was able to essentially do routing through API Gateway myself. I tend to prefer not to use Express because I find it's a bit lighter, but a lot of people like the idea of using Express because it adds additional features on that isn't available by default. There is really no right or wrong answer there. If you like Express, go ahead and use it. If you don't really feel like it's needed, then go ahead and not use it. It's really completely up to you. Augustine asks, where can I download the presentation? Well, we are recording this, and we plan to put it on YouTube, for example, and we'll probably send out a notification then to everybody on Twitter and so on when the presentation is available on YouTube. Patrick Loftus asks, has Lambda cold start times been reduced or mitigated over time? Yes and no. So Lambda cold start times are always improving. Right now, I tend to see cold start times being on the order of tens of milliseconds, but it ultimately depends on what your Lambda uses. It's a very difficult question to answer completely. But the other side of the coin of this is that Lambda cold start times, I think personally, I've found that they tend to be a bit overblown. It's a difficult concept to try and describe in the format we have here as a Q&A. But what you find is that in any system that gets busy enough, your cold start times matter less and less, simply because as traffic increases, your number of warm Lambdas increases well. So the proportion of people experiencing cold start times for Lambda become vanishingly small. And this is from experience working with an organization of over 1 million page loads on a quiet month, and having a Lambda loaded every page load, where you see as traffic increases, those Lambda cold start times start vanishing because you have so many warm Lambdas sitting waiting for traffic to arrive. But again, this is one of those features where if you are sensitive to that kind of latency, you need to experiment and see what works for you or what doesn't. But in general, Lambda cold start times are overblown, and you really should be experimenting for yourself to see if it actually has any effect. And in my experience, I have not seen cold start times actually really have a negative effect on the applications I've built. Arturo Maltos, and forgive me if I'm pronouncing names incorrectly, is it possible to use serverless framework with Aurora serverless and provision all the resources needed for that purpose? Would it be possible to have a GUI configuration generator to customize which resources we need to get deployed together with serverless framework during a deploy? So the first part of the question is, if it can be defined through CloudFormation, then yes, you can do it with serverless framework. There are some issues with, at the moment, unfortunately, with looking at RDS, using RDS as your data source, purely because of what VPC does to cold start times. That's one of the biggest ones. Just taking a sip of water. But there are some interesting movements in that area at the moment. Serverless has, AWS, has recently released news about its data API that it is creating. It's still in a bit of an immature stage right now. They're still refining it. It's a lot better than what they used to have for accessing Aurora Serverless through sort of an API instead of directly through SQL connections. But that space is improving dramatically, and that's a definite place to keep an eye on. As far as GUI configurator to generate resources, at the moment there isn't one available that I'm aware of. And I haven't used one, but what I have found very useful is to keep track of CloudFormation documentation on AWS. And in general, what I tend to do is if I need to configure something like that DynamoDB table you saw me do, I'll go into Google and just type DynamoDB CloudFormation. And the first link is usually the documentation for AWS for the CloudFormation for that resource. So if I want to do Aurora Serverless, I can go Aurora CloudFormation in Google, and I'll probably get to the right place. Lorenzo Giuliano. I've used serverless for around a year until version 124. I remember error tracking, especially Lambda function crashing, was a bit of a pain. Do you think the enterprise panel is solving that issue? Yes, it's going a long way to that. And the features that I showed tonight were just some of the features that are available on the dashboard, but there are plenty more coming that is in development. One of my favorites is notifications. So we are going to be pretty soon adding the feature to send notifications to a Slack channel, as well as to SNS. So you can therefore configure SNS to send those notifications via email or via SMS or to a Lambda function, so you can handle your errors any way you like. But yes, it's definitely helping to solve that problem a lot more, because it's far more apparent when there's an error when you've got that little orange bar showing you that there's errors happening, as well as the alerts panel next to it that you can, like I said, push notifications. So yeah, that's going to help with error tracking a lot more. Yogesh Dev is asking if the recording will be available. Yes, it will, as I said before. And how can we use serverless to deploy microservices? So Rohail Khan asked that. And the demo is kind of trying to show how you can do that. So this was a very simple demo for obvious reasons. We don't have 3 hours necessarily to do a demo. But this is there are many ways to look at how you manage your microservices, how you manage them through your version control. I tend to like the idea of keeping every service in its own Git repo, for example, and using CI/CD, so that when a developer creates a pull request into my develop branch and it gets reviewed by the team, the pull request gets accepted into the develop branch, and my CI tool will automatically deploy those changes into my dev environment that then can run some testing. And once everybody's happy that the testing is okay, the develop branch gets merged into master, and that does maybe additional testing, or it gets deployed into production at that point. That's one way. That helps you manage multiple services that you're building. The idea with the serverless framework is that you can easily spin up additional services, and you can very easily incorporate additional AWS services into your functions that you want to use. I've seen mixtures and built services with mixtures of API Gateway, SNS, Kinesis, SQS, DynamoDB streams, and a whole bunch of other services all in one, and build a really rich and very asynchronous and performant service as a microservice. Yeah, you can definitely use servers to build and deploy your microservices. Is serverless framework support creating ALB? Funny you should ask that, Karthi Muthuswamy. Our recent release of the serverless framework supports ALBs, version 1.45, which was released a couple of days ago, and a blog post will be going out soon about the new release, includes ALB support. So if you don't like API Gateway, if you don't use the advanced features of API Gateway, and you want to try something that's a bit cheaper, you can use the serverless framework to create an ALB to direct your HTTP requests to your Lambda functions in that way instead. So that can be a nice cost saving. And Andrew Platter, this is the last question. I think we're going to leave it there for any more pop-ups. Sorry, guys. It's getting a bit late. Andrew Platter asks, do you support GraphQL APIs? And yes, we do. Well, we don't. AWS does. AWS has a service called AppSync, and AppSync is completely configurable through CloudFormation. So you can actually use a serverless framework to help you configure a your GraphQL endpoints, as well as where they point to, which DynamoDB tables. Maybe you point them at a Lambda function instead, which can then return the data that you want for that specific GraphQL endpoint or query, sorry. So yeah, GraphQL is completely supported. Anyway, thanks so much, everybody. This was a lively a webinar, and I think we'll be probably be doing something like this again in the future. Thanks so much, and just keep a lookout for the announcement of the webinar going on to YouTube, and then at that point, feel free to share with anybody you think might find it useful. Thanks so much, everybody. Goodbye.